In this video, we are going to take rectangular, which are xy equations, and we're going to convert them into polar equations, which will have r's and thetas. This will be similar to converting the coordinates, which we did earlier, and we're going to use the same conversion equations that we used before. So when I look at this rectangular equation, x equals 5, again, I might even think of what the graph of this is. It's a vertical line at 5, but I know I want to get rid of the x and somehow get r and theta into the mix. The conversion equation that stands out to me is x equals r cosine of theta. So I'm going to substitute that in for x, and then this equals 5. Polar equations are typically left in r equals form, so I'm going to continue to get this equation into r equals form by dividing by the cosine of theta. If I don't like the way this fraction looks, I could also create a new equation which would read 5 secant of theta, because 1 over cosine is the same as secant. So r equals 5 secant of theta is my polar equation. If I wanted to compare graphs and see if I actually do get a vertical line at 5, I could go to polar mode, and when I do that and hit y equals, it gives me a bunch of r equals equations, and I would do 5 over the cosine, and my variable button will pop up as a theta. So kind of a cool check. Again, you do have to make sure you're in polar mode. You also need to make sure that you are in radian mode. These thetas will be graphing as radians. Another rectangular xy equation is this one. Now this one's a little more complex. If you don't recognize it, it is the equation for a circle. And we've got an x and a y, and we've got some squares going on. So it's a little more complex than the earlier one. To get all your conversions correct, it would be easiest to actually multiply this out. So I'm going to quantity square this. So I'm going to do that real quickly here. Y squared plus 2y plus 1 equals 10. As I look at condensing this equation down a little bit, I do notice that my 9 and 1 make 10, and when I subtract it to the other side, those would cancel out. So right now I have x squared. I'm going to rearrange the order here, plus y squared minus 6x plus 2y equals 0. I did that because I recognize x squared plus y squared is one of my conversion equations. It equals r squared. Now I could replace my x with r cosine of theta. I can replace my y with r sine of theta. So right now I've got all my r's and thetas. X's and y's are gone. The goal is to get this into r equals form. Because I have r squareds and r's, that's going to be hard unless I factor out an r. So I have minus 6 cosine of theta plus 2 sine of theta. That equals 0. This is in factored form now, where set equal to 0. So I have an equation that reads r equals 0. I also have an equation that reads r equals 6 cosine of theta, if I add that over, minus 2 sine of theta. So these are my polar equations. Incidentally, this, because it's at 0, is just a single point. This point must fall on the graph of this polar graph. This polar graph probably won't look familiar to you right now. We haven't done a lot with graphs, but if you try it, what you should get is a circle with a center at 3, -1, and a radius of square root of 10. So the connection between the rectangular and polar is there, and the point 0, 0 is probably on that circle. So that is how you do some conversions using those conversion equations that we've been practicing.